Hi everyone, this is a video in chapter 6 on measurement, and we will see circles, arcs, and sectors, surface area, volume, and capacity. In previous years, you should have studied measurement extensively. In this chapter, we revise the measurements associated with parts of a circle, as well as the surface area and volume of three-dimensional shapes. So, circles, arcs, and sectors. So we have a circle. This would be an arc, and here is a sector, which is part of a circle. For a circle with radius r, the circumference, as we know, is 2 pi r, and the area is pi r squared. An arc is a part of a circle which joins any two different points. That would be an arc. It can be measured using the angle theta, that's the angle here, subtended by the points at the center. Arc length would be the angle over 360 times 2 pi r. So the angle out of the 360 times 2 pi r, which is the whole circumference. The sector is the region between two radii. Radii is the plural of radius of a circle and the arc between them. Perimeter, that would be the two radii and the arc length. 2r plus pi over 360 times 2 pi r. Okay, the length of the arc plus the two radii. And the area would be the angle over 360 times pi r squared, which is the area of the whole circle. So that would be the ratio between the angle and 360. For the given figure, find the three significant figures, the length of the arc, the perimeter of the sector, and the area of the sector. So we have the angle and we have the radius. So the arc length would be theta over 360, which is 48 over 360, times 2 pi times the radius. So that is rounded to 251 centimeters. The perimeter would be the arc length plus the two radius. So that is 6 plus 2.51. And the area of the sector is 48 over 360 times pi r squared, which is 3.77 centimeters squared because it's area. So here we have finding the perimeter of the whole circle in this case, where this is the diameter. Here, using the formulas that we've seen, here is still the same 260 over 360 times the radius to give us the perimeter, plus 6.2, and another 6.2. In this case, which is more interesting, so we have, we see that this is, each of them is 14. This is 14, and according to these lines, this is also 14. So we can find the length of this arc and the length of this arc. Here the radius is 14, and here the radius is 28. And once we find this and that, we can add 14 and another 14. Let's see, in this case, find the area off. So here again, we have a diameter, which is 13. So the radius would be 6.5. And we have the area using the formula of pi r squared. This case, now it's 90 degrees, so theta over 360 times pi r squared will give us this area. Same for this. And here, we're getting 100. So we know that this angle here would be 260 because 360 minus 100 will get this angle. Here we have same, just without this the drawings. Let's see where we have more interesting questions. And okay, if we know a running track consists of two straight segments joined by the semicircular ends, as shown, the total perimeter of the track is 1600 meters. So that would be also 500, as this is 500. Together it's 1000. This means that each arc here is 300, because altogether it's 1600. If determine the diameter of the semicircular ends, so we can use, this is a semicircle, so it's 2 pi r over 2 in this case, which is also like 180 over 360 will be dividing by 2. So that is pi r. Pi r equals 300 and r equals 300 over pi. Jason takes 4 minutes and 25 seconds to complete a single lap of the track. And by the way, this is the radius, the diameter would be 2r. And to complete a single lap of the track, calculate Jason's average speed in meters per second. Meters per second. So we need to change, first of all, this 4 minutes and 25 seconds into seconds only. So that would be 4 times 60 plus 25, which is 265. And complete a single track, and the track is 1600. So then we can find the average speed. And let's look at some more questions in this case. This is the more interesting. Again, when we have, when we need to find two forms, two figures, two parameters, that would be the more interesting questions. So x and xy are the centers of the circles containing the two arc AB. So for y, that would be the arc, and for x, that would be the arc. Find the length of AX. Finding the length of AX. So that is 16, so we can use Pythagoras to find AX using Pythagoras. X squared plus x squared equals 16 squared, and solving for x. The perimeter of the shaded crescent, so the perimeter we need to find for one, this, okay, where it is. We were looking for this, then the radius is 16 with a 90-degree here. And for finding this arc, the center is x, and we found the radius in part A. So, and this is in 180, so it's half a circle. The area would be the same trick. Okay, that means we need to find, first we can find the whole half a circle, and we can find this, and we can also find the area of the triangle, and by subtracting all these areas, we can get to this shade, okay? The same can be done for those two as well. And so good luck trying those exercises, questions in the book, and look at the final solutions to see if you got it right. Good luck.